Hi guys, welcome to our YouTube channel VLSI Talk. In this video, we are going to see about the basic ASIC flow. Okay, what is the ASIC flow and what are the steps in this ASIC flow? And before going to know about this ASIC flow, you must have to think what is an ASIC, ASIC. What is an ASIC, and what is the purpose? Why we are learning this ASIC flow? If I ask the same question to any recent graduates or BTech students, they'll said like ASIC flow is just a topic in VLSI, just a one simple topic in VLSI, or it is a 14 marks question. They'll say like that, right? But ASIC flow is not only a simple topic in VLSI, it is the entire process of VLSI. Okay, how the chip we are designing and what are the stages it include, all these things will have in this ASIC flow. Okay, you must have to know about this ASIC flow. Whoever are interested to join in VLSI industry, okay, you must have to know about the ASIC flow very clearly. Okay, in this video I'm going to create some basic idea of this ASIC flow. And coming to the ASIC, what is an ASIC? ASIC stands for application specific integrated circuit. Okay, application specific integrated circuit. What is meant by application specific? As its name suggests, that application specific is nothing but we are creating, we are manufacturing a chip to do some certain task or certain applications. That is nothing but an application specific. And what is meant by an IC, integrated circuit? Integrated circuit is nothing but a collection of electronic components. That is the meaning of integrated. Okay, integrated is nothing but a collection. Integrated circuit is nothing but collection of electronic components. Okay, all components will place in one tiny chip. All components will stuffed into some single tiny chip, and this is nothing but an ICs. In day-to-day life, you will see lot of ICs in your laboratories, like op amps, triple fat timers. Those are all ICs. Okay, many more examples are there. I just mentioned few of them here. Okay, triple fat timers, voltage regulators, microcontrollers, anything. Those are all comes under ICs. Now, now we'll see about the ASIC flow, application specific integrated circuit. Up to now, we discussed about the application specific. What is the application specific and what is the integrated circuit? This is a flow chart and this is a diagram. These are the steps which we discussed in detail in couple of minutes. And this is the ASIC flow. And here, if you observe it clearly, this dotted line, I mentioned here it is a front end and here it is a back end. And I didn't mention anything with this synthesis and DFT. The reason why I didn't include these things, these two, some companies will treat these two like in front end and some companies will take these two in the back end. So that's why I didn't mention here anything. And yeah, we'll discuss each and every topic in detail. You can see the categories, what is the front end and what is the back end. Here we separate in the two categories, right? Those two categories. And some students will be like the front end was good and some students will be like back end, and some will take the suggestions from the seniors or their relatives. Don't be like that. Okay, I'll try to give the basic input. Don't be like some seniors are suggested to take PD and some are suggested to take verification. Don't be like that. Okay, whatever you are interested, just go to that domain. Okay, and coming to the first step, system specification. Okay, if you are reading any heading, you may by reading itself you got a lot of info. If you understand the heading properly, I got a lot of info. Here, system specifications. What is the meaning of specification? Specification in general, the specification means a clear plan or a detailed description. That is the meaning of specification. What is a clear plan or detailed description? System related. We want to manufacture a chip, we need some specifications, right? For example, if you want to construct a house, we need some specification like 1 BHK or 2 BHK or 1 RK. What house do we need? We'll tell some specifications, right? I need 2 bedrooms and 1 hall, that is in L shape. That is nothing but a specification here. In ASIC Flow also, we need some specifications to manufacture a chip. Okay? That is nothing but a system specifications. What is the specifications? They'll tell. The customer will define the specification like the chip area, how much of area the chip must be in this area, the chip must be in this size, and power requirements. What is the power requirement of the chip? The chip must be operated with some voltage like 0.3 volts or 0.5 volts. Okay, these are the specifications the customer will give. They'll tell that the specification in their language like plain English. Okay, they'll not gonna write any code or anything. They are customers, right? They'll just tell the specification. Just like I need a chip with this size, and it must be operated with the power of 0.3 volts or 0.2 volts. They'll give some specifications. And the next thing, the architecture design. The architecture engineer will do the design. They'll take the specifications from the customer and they'll design the blocks. Okay, what is the blocks in that design? According to the customer specification, they'll design the blocks and they'll design one architecture of the chip. Okay, where the blocks will be placed. All those things will take care of the architecture design. Similarly, in our house construction also, you will tell to engineer like we need 1 BHK and the hall should be L-shaped. We will give some specification and they'll draw the engineering plan of our house. Right? The same thing here also. The architecture engineer, what they will do, they'll design one architecture of the chip. Okay, here they're not gonna write anything. They'll just design the architecture of the chip. Okay, that is nothing but an architecture design. And the next thing, the next stage is RTL design. Here it is also a design, the RTL design. RTL stands for register transfer level. In this step, the RTL design engineers, what they will do means, here in architecture design, they just design the blocks. They'll just design architecture. Here in RTL design, they'll write a code for that blocks. Okay, they'll write a code. What code? In VLSI, we'll use the codes like HDLs, like hardware description language, such as Verilog and VHDL, and they'll define the behavior of the each block. To understanding purpose, how the system will understand hardware through hardware description language only. That is the reason the RTL design engineers, what they will do, they'll take each block and they'll write a code for that block. Okay, they'll write a code. Which code? Hardware description language. The code is in the hardware description language. Whatever the functional blocks are there, they'll define the functionality of the block by using the hardware description languages. That is nothing but a RTL design. Okay, the task of the RTL design engineer is to write a code, write a hardware description language code to the blocks which they defined in the architecture design. And coming to the next stage, verification. Once the code was written, we don't go next process directly. We don't go to the next stage without any verification. So each and every stage will do the verification. We'll do the test. Some tests are there, some verification. We'll cross check. Everything will cross check. Verification. It is also some separate domain. Verification, design verification engineers are there. What they will do, whatever the code written by the RTL engineers, they'll verify for the functional correctness, whether the code is working fine or not. Okay, whether the functionality of this block is working as expected or not. Okay, they'll write many test cases to do verification. Okay, they'll write many test cases. They have some tools to simulate all these things. They'll use these tools and they'll write test cases and they'll verify. Once the verification was completed, then next stage was the synthesis. In this verification, if they get any errors or the design is not working as they expected, again they'll go to that RTL stage, RTL design engineers. They'll inform to the RTL engineers and they'll again recorrect the code, and this process will continue until the verification get a green signal. Okay, once the verification engineer gives the green signal, then the next stage is the synthesis. From this onwards, the real magic will happen. So far, it's only the first the customer will give whatever the specification in simple English. Then next architecture design. Architecture will give one architecture and RTL engineer. He'll write the code in HTL. Okay, in very large way HTL in language. And next verification was done. So far, it is only in description only, not a physical thing, right? In synthesis, what you will do means the code, whatever the code, RTL code is written by the RTL engineer, it will take the synthesis engineer will take the code and he will generate the netlist. What is the netlist? If they wrote code for AND gate, for example, take AND gate. If they wrote code for AND gate, in synthesis, the tool will take the AND gate code and will convert into the netlist. Means logically the tool will understand, okay, it is an AND gate. Whatever the text is there written in HTML format, this is for AND gate. So the tool will change it to the AND gate until it is just a text only. Code is also text, right? But in synthesis stage, it will convert into the real time. It will convert into the component. Okay, AND gate code it will take and it will convert into the AND gate. Logically, it will convert into the AND gate. Okay, it is an AND gate, and it will place. That is the real magic here. Up to now, only the code is in the description. Just it is in a text format only. While coming to the synthesis, it will place that AND gate in the chip. Okay, whatever the code they will written in the RTL, it will convert. It will become real here. For example, if you remember the 90s serial G Boomba, there is one pencil called G Boomba. Whatever you have written with that pencil, it will convert. It will transform it to the real thing. I bought that pencil at the time, but it's not worked for me. That is how the synthesis tool will work. It will convert the RTL design into the gate level netlist. Once the synthesis was done, and we'll do many things in synthesis. I'll tell you in detail and coming to the PNR flow. I'll do a separate video about this. Once the synthesis was completed, the next thing is a DFT. DFT. DFT stands for Design for Test. DFT stands for Design for Test. What is this DFT and why we use? As its name suggests, DFT, Design for Test. Our design consists of number of flip-flops and number of cells are there, right? Number of components are there in our chip. If any component is not working perfectly, then how you will know? If your design consists of millions of transistors or millions of flops, if one flop was damaged and you don't know which flop was damaged, then how you will get to know? So that is the reason they included a step called DFT, stage called DFT. DFT engineers are there. What they will do means they will replace the normal flip-flops with the scan flip-flop. Okay, in this step they'll insert one scan chain. Each and every flop will stitch to the scan chain, and they'll replace the flops to the scan flip-flop. What is the scan flip-flop? Scan flip-flop is nothing but just two extra pins are there. One is scan input and scan enable. Okay, whatever the scan input is used for testing purpose, whatever the input we are giving to the scan input, we'll check for the output whether it is giving correct output or not. Okay, if it is giving the correct output, then flip-flop is working fine. If it is giving some false output, then flip-flops are not working fine. That is how they'll analyze in DFT. It is used for testing purpose. Why? Because the chips are very small, right? We are not ant-mans. We are not having a power of ant-man. If you go into the chip and we'll check. Yeah. So that is the reason DFT team is there. They'll insert the scan chain. They'll send some scan inputs and they'll check whether the functionality is as expected or not. Okay. That is the usage of this DFT. And coming to the next stage, physical design. Most of you are aware of this thing, physical design. Why? Because so many of your relatives or your friends will suggest you to take the physical design, because they'll say it like you get a more higher packages in physical design. That is not true. Any domain VLSI will have similar packages only. Don't go for packages. Just go for your interest. Okay. Anyway, I'm not going to discuss about that thing. Here, physical design, as it names is that physical. So far, we'll place the cells in logical only. We didn't take any physical layout. But coming to the physical design, we'll place the cells physically. We'll place the cells into the chip area. Whatever the core area is there, we'll place the cells into the core area. That is, so that's why the physical design is also called as PNR and place and route. Place means we'll place the cells, and route means we'll interconnect all the cells. That is what we done in the physical design. As a physical designer, you have to place the entire cells. How many cells are there in your design? You have to place the entire cells in your core area, and we will interconnect them. We're not doing by manual. There are a lot of automation tools are there. Okay, that is nothing but a physical design. And the next thing after physical design is physical verification. As I mentioned earlier, you have to verify each and everything, right? In physical verification, the team will verify, will check for any design rule violations are there or not, and they'll check mainly check for LVS and electrical ERC. There are a lot of checks are there in physical verification. If anything is they have DRMs, design rule manuals. Based upon that, they'll fix some things, okay, layout things. And the process will be these things will take care in physical verification. In some companies, the PD engineer, physical design engineer, will have to take care of all these things. And in some MNCs, top MNCs, PV team has separate. Okay, physical verification has separate team is there. Most of the cases, PV will take care of the separate team. And the next thing is the sign off. Sign off is nothing but a green signal, like it is a green signal to the fabrication. Once the PD and PV is completed and sign off, they'll check if there any timing violations or is there any other violations in the design. The entire violations it will check. They take the block and they'll check the violations. They'll check for any errors are there. Why? Because if any single error or if any small minute error is there, it will damage the chip. Okay, it is very costly process. So that's why we have to take care of each and every stage. Okay, in sign off, it is like a green signal. Okay, if the sign off reports are clean, then it is good to go the tape out or fabrication. Okay, that is nothing but a sign off. And what is the tape out or fabrication? Fabrication or tape out are nothing but once the design was verified, all the sign off checks was done, and it is good to go. Then the design was sent to that foundry. Foundries are nothing but TSMC foundry, Intel foundry, Samsung foundry. There are a lot of foundries are there. They'll manufacture the chip. They'll take the wafers and they'll do the manufacturing. Okay, whatever the customer specification. So far, what we have done, we take the customer specifications and we done the architecture design. And with that architecture design, we wrote the functional code. RTL engineer wrote the functional code, and it is verified by the design verification engineers by writing various test cases. And after that, it will send to the synthesis stage. What synthesis engineer will do? Synthesis engineer will convert that thing into the gate level netlist, and it sent to the DFT team, and DFT team will insert the scan chains for testing purpose. And next, it is given to the physical design engineers. They will place the cells. They'll place the cells into the design, and physical verification. Physical verification. They'll check for the any violations, and they'll fix that violation and give to the sign off. And again, they'll check for the violation, and they'll if there any violations are there, they'll fix, and they'll send to the fabrication. In this fabrication, they'll send to the manufacturers like fabs are the TSMC, Intel, Samsung, many foundries are there. They'll send to the fabrication, and they'll make the photo mask. Okay, I hope you aware all these things, photo mask, the fabrication process. If you didn't aware also, I'll do a separate video. Okay, that is nothing but a tape out. Okay, they'll send to the fabrication. They'll do the fabrication process. They'll create the photo mask for the required chip, and they'll do the fabrication. That is nothing but fabrication. Once the fabrication tape out is completed, then again one more thing is that packaging and testing. Once the chip was manufactured, again they will check whether the chip is working as expected or not, whether it meets all the requirements or not. Okay, if you have any doubts regarding this ASIC flow, please do comment. I'll try to explain. And remember this point, it is not a topic to by heart. Okay, it is a life cycle for the VLSI engineer. Yeah, thank you guys. I hope you enjoyed the video. If you like this video, please do share and subscribe to our channel. Yeah, thank you.